Hello dear viewers, I am Mr. San Hamduni. This video is on grade 9 chapter 4 electricity and electronics. So let's get started. So the learning objectives are as follows. Outline the generation and use of electricity. Identify and describe the functions of electrical and electronic components. Construct simple electrical and electronic circuits using appropriate tools. And also observe safe working practices when working with electrical or electronic components. So let's outline the overview of this chapter. We are going to have a look at the introduction to electricity, generation and use of electricity, electric circuit, Ohm's law, electrical tools, as well as introduction to electronics, basic electronic components, and safety. Electricity and electronics play a key role in our everyday lives. We are dependent on devices that rely on electrical power to operate. Did you know that electricity came to Mauritius in 1899 and a turbine was set at Réduit? And the first hydro station was made operational at Tamarind Falls in 1903. Electricity is used to operate so many different devices. Now let's have a look at how electricity is generated. So there are three key stages, from generation to transmission to distribution. Electricity is generated at a power plant. A power generation plant is a facility designed to produce electric energy from another form of energy such as heat, energy generated from fossil fuels, examples are coal, petroleum or natural gas, solar thermal energy, geothermal energy, nuclear energy, other forms of energy that are used to produce electricity or potential energy from falling water in a hydroelectric facility, wind energy, solar electric from solar photovoltaic cells, and finally through chemical energy from fuel cells or batteries. There are many types of electric power generating plants. So when electricity is generated in a power plant, it is transmitted along wires and then it reaches our houses. The map here shows the different types of power stations that exist in Mauritius. Currently, there are 4 thermal power stations, namely Saint Louis Power Station, Fort Victoria Power Station, Fort George Power Station, and Nicolet Power Station. There are 10 hydroelectric plants, and there are 17 independent power producers. Here you can see images of the different power stations that are present in Mauritius. The Fort Victoria Power Station is a thermal power station, which means that it uses heavy fuel oil as primary energy. It is then converted into electrical energy. The Nicolet Power Station uses kerosene as primary energy to produce electricity. Electricity has become a fundamental source of energy. The reason is because electricity can be transported or transmitted through wires over long distances. Electricity can also be changed or transformed into a different kind of energy. For example, the vehicles that move us around the world are controlled by electricity. Ships use sonar and radar to keep them on course. Airplanes use electronic components in their radar and automatic pilot systems to help make flights safe. Banks rely on electronics for security and for the accounting of our money. Factories and industries use electronics to control assembly lines, inventory, quality or precision engineering. Hospitals use many devices with electronic components. These devices are used to find out what is wrong and then treat the patient for the problem. Space shuttles, trains, satellite signals, and even law enforcement use electronic technology. So electricity can be defined as the movement of electrons in an electrical conductor. Electricity is a form of energy and it can be converted from one form to another. The flow of electric current is from the negative to the positive poles. Current is measured in amperes. The movement of electrons is caused by an EMF. EMF stands for electromotive force, and this EMF it is measured in volts. Resistance is a tendency of a material to oppose flow of electrons, and this resistance is measured in ohms. Later on in this video, we are going to understand the relationship between current, voltage, and resistance. We are now going to look at an experiment which will help us better understand electrical circuits. So there are two circuits, A and B. Which one do you think the bulb will light up, in A or in B? Yes, the bulb will light up in circuit B. The reason is because A is an open circuit whereas B is a closed circuit, which means that electricity will flow from the battery to the bulb. So how do we open and close a circuit? At home you might have used light switches. So similarly, here we are going to use a switch to open or close a circuit. Now, what are the key components of an electric circuit? These are the power source, conducting wires, switch, and the load. So conductors are materials which allow flow of electricity. They have free moving electrons. Basically, all metals they conduct electricity. And the best electrical conductor is aluminium. However, copper is cheaper to produce. This is why copper is used extensively in wires. Contrary to conductors, insulators are materials that do not easily transmit heat, cold, or electricity. Therefore, electrical wires are covered with an insulator to prevent electrical shocks and short circuits that could cause fires. Plastic, rubber, and glass are the main insulators that are used. Now we are going to study Ohm's law. So Ohm's law states that the flow of current is directly proportional to the electromotive force between 2 points. So when we look at a circuit, we'll understand that the battery is going to produce the EMF. Therefore, the electrons move from the negative pole to the positive pole and it creates a loop. The bulb will light up only when the switch is closed. Ohm's law can also be represented in this formula: V is equal to I multiplied by R, which means that V is the electromotive force, I represents current, and R represents resistance. Voltage will be measured in volts, current will be measured in amperes, and resistance will be measured in ohms. Let's have a look at an example. So the example is as follows. A current of 0.25 amperes flows through a 36 ohms resistor. Calculate the supply voltage. So here we are going to use the formula V is equal to IR. To find voltage, we are going to substitute 0.25 amperes for I and 36 ohms for resistance. When we multiply these two, we are going to obtain 9 volts. The other exercise is as follows. Calculate the resistance of a wire when a potential difference of 12 volts is applied across it and a current of 4 amperes flows through it. Here we have been given two parameters. The first one is the potential difference, which we can also refer to as the EMF, and the current is 4 amperes. We are going to use the formula V is equal to IR. Since we have to calculate the resistance, we have to make R subject of formula, and we'll obtain this formula. R is equal to V divided by I. So we are going to divide 12 volts by 4 amperes, and that would give us 3 ohms. So both of these exercises show how we can use Ohm's law to calculate either voltage or resistance or current in a circuit. When we talk about electrical components, we are going to refer to the first main component, which is a 3-pin plug. We are going to have 3 main wires in an electrical wire. In an electric wire, there are 3 wires. The neutral wire, which is blue, the live wire, which is brown, and the earth wire, which is yellow and green, are seen in this diagram. The fuse is a safety device which forms part of the 3-pin plug. It blows when there is a short circuit. Here we have 4 exercises. A light bulb with resistance of 2 ohms is connected to a 4 volts battery. What is the current flowing through the circuit? So here we are going to use the formula, which is V is equal to IR. We have to find current. Therefore, we are going to make I subject of formula, and I will be equal to V divided by R, which would give us 4 divided by 2, and the answer would be 2 amperes. Define resistance. Resistance is the tendency of a material to oppose flow of electron. What is the relationship explained by Ohm's law? The flow of current is directly proportional to the electromotive force between 2 points. Question 4. A simple circuit contains only wires. A resistor drawing a current of 0.83 amperes and 1.5 volt battery. What is the resistance of the resistor? We are going to use the equation from Ohm's law, where V is equal to IR, and since we have to find the resistance, we have to make R subject of formula. So R is equal to V divided by I. 1.5 divided by 0.83 will give us 1.8 ohms. The electric tools that we use when carrying out electrical works are as follows: a wire cutter, wire stripper, test lead, soldering iron, desoldering pump tool, tester screwdriver, multimeter. The next part of this chapter is electronics. Electronics plays a crucial role in all the electronic devices that exist today. from your mobile phones to your smart TVs to your laptop or any other devices, electronics help to carry out very complex tasks. This is a circuit board from a computer. As you can see, there are very tiny components, and these components are electronic components, and each one of these little components, they play a very important role. They form a circuit that help to carry out specific tasks. This is another circuit board which is found in our mobile phones. So electronics mean the study of flow and control of electrons in electrical circuits. For example, an air conditioner, it uses electricity to operate. It takes out heat from the inside of a room to outside. But to measure the temperature, electronics is used. All electronic circuits consist mainly three components: input, control, and output. Cells and batteries, they are a source of power. Resistors in a circuit are used to resist the flow of current or to control the voltage in a circuit. A variable resistor is a type of resistor which is used to change resistance. For example, in your radio, when you use the volume knob to either increase or decrease, this is a good example of a variable resistor. Switches are used to control the flow of electricity in a circuit. They either close or open a circuit. Capacitors are devices that can store charge, and LDR, which means light dependent resistors, in which the resistance changes with light intensity. A thermistor is another type of resistor in which the resistance varies with temperature. A diode allows electricity to flow in only one direction and prevents it from flowing in the opposite direction. A light bulb is used mainly to provide illumination. LEDs, which mean light emitting diodes, they emit light to give signals. Electric motors are simple motors that are used in circuits from toys to hair dryer or shaver. A buzzer is mostly used in alarm systems to give signals. A speaker converts an electric signal into audible sound. Here we find an exercise in which you have to complete the table by filling in the corresponding symbol or the name of the symbol. You can pause the screen to copy the table and answer. In this table, you have to write all the electronic components that you have seen in the previous slides, and also draw the symbol and write a very simple function. Safety is very important factor when we work with electrical and electronic systems. The first safety that we have to observe is that we have to turn off power and unplug devices when checking or replacing parts. We must not touch electrical appliances and wires with wet hands. We have to use proper tools and equipment with adequate insulation to prevent electrocution. We have to regularly check for damaged wires and plugs. We always have to replace. We must not repair. We have to use gloves and appropriate footwear to protect us. We must also avoid overloading electrical sockets and plug extensions. Earthing is very important when we talk about safety. Imagine that an electrical fault causes the live wire to be in contact with the washing machine's metal casing. What will happen if you touch the washing machine's metal casing? Obviously, you will get an electric shock. Earthing can prevent electric shocks. So, the excess current is going to flow to the ground, as we can see here. So even though the live wire is in contact with the metal casing, the current will flow to the ground because it is the easiest and fastest path for electricity to flow, and therefore the person will not be electrocuted. So here we have a few revision questions. You can pause the screen so that you can copy the questions and answer them. You have to complete the table by either inserting the name of the electronic component or the symbol or the function. We have finally reached the end of this video. I thank you for your attention, and if you have any questions, feel free to send me a message on my WhatsApp number. Please like, share and subscribe. If you found the video useful, consider sharing it with a friend. See you soon and take care.